Hey guys, I'm Sun. I'm a privacy and a security researcher, and you're watching the Privacy Guides. In today's episode, we're going to set up our own hardened Debian server, actually in the context of setting up a virtual private server. So I'm not sure, of the people who are listening to this, who knows what the cloud is. I saw a quote a few days ago that I really liked, and I'm going to screw it up here, but the cloud is essentially someone else's computer. So the cloud is not this magical thing. It's essentially clusters of computers that usually use concepts of virtualization in order to run multiple compartmentalized operating systems on the same hardware, because computers are now very powerful and can run multiple servers. Now, why am I saying all this? Well, one value that I really believe in is sovereignty. I think that as people who are using technology, technology has centralized itself and is now in the hands of very few. So you can think about AWS. When Amazon started, they needed their own infrastructure. They created some abstraction layers that became AWS. And now a whole bunch of the world's servers are at AWS. I think roughly 30% of the internet traffic is going through AWS at some point or another. What's very interesting is actually that Netflix is hosted on AWS, and now Amazon Prime is competing against Netflix anyways. So all that said, not all providers are AWS. There's a bunch of really nice providers. I created an episode a while back talking about 1984 and Niala, and I'll link that in the description. Those are two providers that are really privacy conscious. I really like 1984, and that's what we're going to be using today. So why in the world would we want to set up our own server in the cloud? Well, to be sovereign, to have more control, so that we don't just use some backends. So if we're talking about Borg, we don't need to use Borg base, or we don't need to use rsync.net. We can actually back things up to our own server. That also applies to setting up VPNs. I did create an episode a while back called something like how to self-host our own hardened Strong Swan VPN. Well, that episode actually used a Debian server as well. As I mentioned in last episode on Borg, I'm creating things now in some kind of a building block way, meaning that this episode, how to configure a hardened Debian server, is a prerequisite for the next episode I'm going to be creating on how to self-host our own Borg server. And then I'm also going to create episodes on how to create our own proxies, so that when using Firefox, I created an episode a while back on how to compartmentalize Firefox using Firefox profiles. And I'm going to show you guys how to use this server as a proxy so that a compartmentalized Firefox instance can actually run through a specific server, so that different profiles in Firefox can actually have different IPs, allowing us to really compartmentalize things. So essentially, setting up our own hardened Debian server is one of those very fundamental building blocks on which we're going to develop all kinds of ideas in the future. So without further ado, we're going to jump in today's episode. It's not going to be a super duper long one like last one. So a virtual private server is essentially a compartmentalized operating system in the context of hardware that is too powerful to host only one server, or at least it's not necessary. So we need a VPS provider. As I mentioned in the past, I really like 1984. It's a VPS provider or hosting provider in Iceland that is privacy conscious. It's possible to sign up for 1984 without revealing who we are, and it's possible to pay using Bitcoin. So it's really a privacy conscious alternative. So once we have a look at the pricing, I'll put that in US dollars. What we're looking for here is essentially a VPS. And for the purpose of today's episode, the VPS number 1 plan is really fine. I created an episode on how to benchmark virtual private servers. I'll link that in the description as well. And 1984 is really good. It's actually pretty close to something like DigitalOcean, which is not privacy conscious, but gives good performance for the price we pay. So shout out to 1984, great provider. By the way, this is not a sponsored episode in any way. It's just kind of like a love story. I really like what they're doing. So, okay. So we need to set this up. So the first thing we want to do is create an account, and I've done that. So this here is my demo account. Once this is done, you would want to go in products and click on order VPS. Say you haven't done that before, and you would choose VPS number 1. Then you can add RAM or disk space, but for the purpose of today's episode, we're just going to go with the basic plan. You don't need to set a host name. The really important thing here is you want to choose the Debian GNU Linux Buster release, not this one, which is pre-configured with a VPN server that I have no clue about, but really this one, which is a raw kind of EASL build of Debian, meaning there is very little software pre-installed, which is what we want because we want to have control over what's actually installed. The next thing here is we need to use an SSH key. Using a root password is not as secure, so we need to generate that. So if we look at today's episode, the first step here is creating an SSH key pair on our computer. So in order to do this, we want to make sure that the .sh folder exists. We then want to go into that folder, and we then want to run this command. And I've done that before. You can follow the instructions here, so I won't do it again. If we look here, we'll see that we have this server pub key and the server private key. So I can skip that step, but you guys definitely have to do it. The next step here is logging in as root, but first things first. Essentially what we want to do, going back here, we want to cat, which essentially displays the content of the file of server.pub, and all of this here, that is our SSH public key, and that is what we want to paste here. Now, as you've seen, as you can see here, I've done that in the past. So essentially what I would want to do is just choose that one, but you guys will probably want to paste it in. SSH key, agree to terms and service, reading them, of course, and then add to cart. Once this is done, what happens, what happens is when we go to our overview, we're going to have a VPS here that we can access through VPS controls, and that will reveal the IP address of that server and its name servers and stuff like this. So that's where you would want to have access to this. I might create an episode in the future. It's actually possible to install Debian from an actual official Debian ISO release. Why would we want to do this? Because we can actually go about encrypting our information. Now, some of you will challenge the fact that encrypting information in the context of a VPS, especially when we don't have the metal, when we don't own the metal, meaning the hardware, that is not that secure. That being said, if we do trust a provider, having this data encrypted is actually good. So that's something that I would recommend, but we'll talk about this in a more elaborate future episode. So, all right, this here is running. That means that we can now SSH to it. So by running this command here, let me just clear this first. By running this command, what we're actually doing is we're connecting through SSH to the server as root. And this here is little snitch. It's asking me, do you want to connect? And yes, I'll allow this forever. It now asks us to confirm the fingerprint. That actually is something that we don't see the fingerprint here. But I'm guessing we could actually confirm fingerprints using the SSH public key that we have, but we'll just consider this to be good for now. And then it's asking us for the passphrase that we created. So in this step here, when asked for a passphrase, we generated a random passphrase using OpenSSL. Whoops. Okay, so I have this in my MacPass, as I said. By the way, super shitty password here. This is a demo computer, so yours should be like a gazillion times more elaborate. So yeah, going into server, I can see that I have this root password here. Actually, no, sorry, the SSH server passphrase. So I can just copy this and paste it there, and we're in. So now that we're in, the first thing that we want to do, and I'm going to be a little... I'm going to go in detail on this. And by the way, some of you might have suggestions. I'll mention how you guys can help at the end of today's episode. But okay, so the first thing that I'm doing here is I'm disabling bash history. That means that all of those commands that I'm running here, I don't want those to be registered in memory once I quit this session. The next thing that we want to do is set the root password. So to set root password, You can use OpenSSL to create a password. If you open a tab and run this, it will create a random 32 characters long password. I've done that already, so if I go in MacPass, you'll see that I have a root password. I'm just going to copy this one and use it. So that is done. Now we want to create a server admin user. It's never good to allow people to log in using root because everyone knows that root is actually something with privileged access. So we're going to start by creating an admin user called server admin, and it's going to ask us for a password. So again, we can use this to generate one. I've done that before. So server admin here, I'm going to copy this and paste it. All right. So now it's asking us for the full name, you know, room number, all of this stuff we don't need to fill out, and we want to say yes, and boom, the user is created. The next step is we want to make sure we create an .ssh folder within the home folder of server admin, and we want to copy over that SSH key that we used to log in as root. And we then want to change ownership of that .ssh folder to server admin. Now that this is done, we log out and we want to log in again using server admin to make sure that we can now authenticate as server admin. It uses the same SSH private key here, so I can copy its passphrase, and we're in. Now that this is done, similarly to what we did for root, we want to disable bash history for that user and then use su to switch to root. For that, we need the root password, so I'm just going to copy this and enter it here. Now that this is done, let's clear the terminal. Whoops. Control sequence, blah, 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 and allow this in the future. Okay. Okay, now next up, we want to disable root login and password authentication and restart the SSH daemon and update the apt index. So the way we install apps called packages in the context of Debian is using apt. It's a package manager. This is actually the Debian equivalent to Homebrew on macOS. Once this is done, we want to go about installing, not installing, but upgrading all of the packages on the server to make sure that it is updated. By the way, Debian is a distribution that is really intended for increased security. It's a distribution that doesn't have all of the bleeding edge versions of applications. So in some use cases, we will want to install stuff from source. We might discuss this in the future. But for those really basic packages, this is absolutely fine. Almost there. Come on, 1% left. Okay, next up is we're going to install Vim. Vim is a text editor that I like. It's something that you guys, well, maybe you prefer using, you know, other editors, but I tend to do this by default, and I also set up my Vim RC file so that it's configured the way I like it. Next, we want to set a time zone. This is for Montreal, but you guys can find the time zone nearest to you here or spoof the time zone to something else. The next step is if the server is IPv4 only, which is the case at 1984 right now, I tend to want to disable IPv6 altogether. This is something that is kind of optional, but I find that better. I don't see why I should handle IPv6 address spaces when the upstream network does not. And then we want to install iptables. Now, by the way, iptables is kind of being deprecated from Debian. I think it's nftables that is replacing it. That being said, I don't know nftables currently. So yeah, if you guys do, maybe you could suggest the equivalent using nftables. But for the time being, there's a translator that works very well. So that's cool. So, okay, save current IPv4 and IPv6 rules. Yes. And then those here, those are all line by line, a bunch of iptable commands that will set up the firewall. So I'm going to run all of this here, and let's just talk about what's going on here. So the first thing here is I'm creating an SSH brute force mitigation thing that will essentially block people who are trying to connect using SSH over and over and over, trying to brute force their way in. So this here is mitigating brute force. We're then allowing everything on the local interface. Then we're allowing access through SSH, but applying that brute force mitigation. Then we're allowing all related and established connections input-wise. And from an output perspective, we're allowing stuff on the local interface. We're allowing DNS requests, HTTP requests, NTP requests, HTTPS requests, and all outbound related and established connections, and we're dropping everything else. Now, if the server is IPv4 only, which is the case at 1984, we want to run this. This is essentially blocking everything on IPv6. If the server was dual stack, this here is what we would want to run as well to configure IPv6 rules. Now that this is done, we want to exit twice. So once will exit us from root, the other from server admin, and we want to log in again. The reason for that is if ever we had locked ourselves out, those rules have not been written to the file system, so we could force a reboot, and that happens here. So we could force a reboot, and that would grant us access again, and we could fix things. So, okay, I need the server password here. Okay. And then we want to switch to root again. So we'll need the root password here. Yes. And now we're committing those rules to the file system, and we're done. So I'm sure I'm missing steps here to harden Debian even more. If you guys have suggestions, there is a way, I've mentioned that in the past, okay, but there is a way for you guys to contribute. So here are ways. So if you value the project, you can start a repo. A lot of you have done that recently. Thank you so very much. If you have a recommendation, please submit an issue. So all of this stuff is done on GitHub. An issue is a way for you guys to express concerns or suggest something. If you find a security vulnerability, you can get in touch with me. And make sure you encrypt that message using my PGP public key. And if you're a fellow privacy and security researcher, and that's what I'm really talking about here, you can peer review and sign a guide. So first things first, you could suggest things if you have recommendations using issues, but also, and that's so very important, I baked into my CMS a way for you guys to peer review episodes. And what that means is when people stumble upon this content and they're not sure if they can trust me, well, together we can establish a web of trust so that people can see who actually co-signed onto this content. So what does this even look like? If we go here in the reference material and we look up the Veracrypt episode, if my memory is good, hopefully it is, Veracrypt. Is this the one? Yes. So this whole episode was peer reviewed by Alex Anderson and by myself. So you can see that Alex is a reviewer. And if you click on Alex, you can go and see his GitHub profile. Alex is also active on Stack Exchange. So that's a way for you guys to know that more than one person actually peer reviewed the content. And peer reviewing content is actually pretty simple. If you go into the docs, and you look at the peer review documentation here, you need to clone the repository, check out draft. So draft is a branch that exists on the repository that is used to stage changes before they're published publicly. And you want to review the guide, submit recommendations using issues. And once we've reached consensus, so please don't just submit a PR with changes. That's something that I try to avoid because it gets messy. If you have recommendations, please use an issue. And once consensus has been reached, issues are closed and updated guide has been published to draft. Time for step 4, which is appending yourself to the reviewers. And this here is what it looks like. So if we look at the source code, and let's just look at, this episode. If you look at the content of the README and you look at it in raw, you'll see that at the top of each episode is a bunch of metadata. And one of this here is the actual reviewers section. So you would want to add yourself to the reviewer and submit a signed pull request. So a signed pull request means you're using your PGP public key to actually sign the pull request. And by signing the pull request, it means that cryptographically speaking, only you could have submitted that, so you're then contributing to the web of trust. This means that only people with public profiles that are known as security and privacy researchers will be considered for those type of peer review pull requests, because establishing the web of trust, well, people have to know that they can trust that person, or else I could just create 12 fake GitHub account and just peer review my own work. So that's it for today's episode. I mean, if we have a look at this again, the Debian server, this is one of those building blocks on which we're going to build in the future. As I mentioned at the beginning of this episode, I have a bunch of content. And next episode will be about setting up Borg on this hardened Debian server to actually self-host our own Borg backend. So yeah, I'll see you soon. Bye, guys.